Intermolecular Forces by Jada Wong. Learning Objective 2.11 states that the student is able to explain the trends in properties and/or predict properties of samples consisting of particles with no permanent dipole on the basis of London dispersion force. I have two shoes. The strap on the shoe on the left is bonded to the body of the shoe, and the shoe on the right is held together with Velcro. The shoe on the left is much like hydrogen bonds because of the large amount of energy that would be needed to remove the strap. And the shoe on the right is much like dipole-dipole forces that have much weaker forces. Wow, what an analogy! The stronger the intermolecular force, the higher the boiling and melting point is. Hydrogen bonds are the strongest and are made with a pairing of hydrogen and nitrogen, hydrogen and oxygen, and a hydrogen and fluorine. Dipole-dipole forces are with polar bonds. This is why F2 is not a dipole, but HCl is. When a solid has to transition to a liquid, intermolecular forces have to break, but when a liquid needs to transition to a gas, intermolecular forces have to form. Here is an example of induced dipole forces. The higher the boiling point / melting point, the stronger the London dispersion forces. Propane can be a liquid, but it doesn't have any dipoles. This encourages us to use Science Practice 3 to engage in scientific questioning to extend the thinking and investigation within the context of the AP course. Induced dipole meaning it's the type of dipole that is formed momentarily when another molecule approaches. The larger the molecule, the easier to be polarized. So propane and butane are still gases at room temperature, but pentane is liquid. It is larger and has a chain of 5 carbon atoms. These two nonpolar molecules have a momentary attraction and repulsion with the nuclei and electrons in the neighboring molecules, which result in induced dipoles. The motion of electrons between the molecules lead to a lower energy and stabilizes the system. The higher the molecular weight and the longer the molecule, the stronger the London dispersion forces, because there are more electrons and the polarization is easier to occur. Science Practice 1, using models to communicate scientific phenomena and solve problems, is demonstrated by clay-pentane models demonstrating the induced dipole forces. Science Practice 7 says that students are able to connect and relate the knowledge across various concepts. Many intermolecular forces can contribute to solubility. If the solute is a solid or a liquid, it first must be dispersed, so molecular units must be pulled apart using intermolecular force. This requires energy and works against solution formation.